Welcome, guys. Yeah. So after remember in the first long videos, we have already computed the mean and variance for the common probability distribution, right? So it's like let's just go back to the first page. I just why this is so slow. Okay. So in the previous video, you can go to my video channel. That we proved that all of these mean and variance. So these are all famous probability distribution. I think it's enough for if you are undergraduate. Then knowing how to prove all these mean and variance is already good for you. So if you have not yet checked my previous video, you can go to my check. I leave the link below that. You can see all the step-by-step proof for all these probability distribution. Okay, so in this video, let's talk about a so-called moment generating function. This is also famous in, I mean, if you study undergraduate probabilities or for also what. Okay, so yeah, the key idea is that this moment generating function for random variable x. If your x is just some real number, then you just take the expectation value of exponential tx, where t is some number. So the idea is that you just change this. I just define this, and the idea is that once you know the moment generating function, then you can get the ex. You can do the expansion and get the first term, second term, third term. So you can get the so-called the mean and the variance from using this minus this square, and then you get the third moment, fourth moment, whatever. Okay. So you can get the nth moment, and then there's a theorem that I did not prove here is that for the group probability distribution, determine all the moments can already fix the probability distribution. This is not easy theory. Okay. So basically, if you have probability, you have two probabilities here. Probability distribution, they have the same moments. For all moments, then they must be the same probability distribution. And this theorem, maybe I will prove in the future video. Okay. So so if you're undergrads, then the one problem, basic homework problem, is that you hope you can. The teacher will ask you to compute all this probability distribution. Yeah. So, but in this video, I think I only prove up to binomial, and I will leave the rest of these, or I will separate this into 3 or 4 videos, and each videos will only prove 3 or 4 distribution. Okay, so we will prove two. One is the moment generating function, one is a characteristic function. So moment generating function is exponential tx, and the characteristic function is idx. Okay, so exponential value is exponential itx, expectation value of exponential tx. So one idea is that if both exist, then you can get the moment generating. You can get the characteristic function just by plugging it for the moment generating function. Okay, so I think this is straightforward. Okay, so let's prove the first 4. Okay, so the first 4 is somewhat trivial. Okay, the first one is f. It's just delta a. This is called the delta distribution. So your mxt, okay, let's say phi xt will be delta x minus a exponential itx dx. So you just replace x by a, right? You get exponential ita. And your mxt will be exponential ta, right? Because mxit will be phi xt. So just this. And Bernoulli, what's Bernoulli, right? You get the x0, 1 minus p, x1 p, right? So mxt will be p times exponential t because x is 1, and 1 minus p exponential 0. So it's p exponential t plus 1 minus p. So phi xt just change t to it. Okay, get this. Okay. Okay, so this is the degenerate Bernoulli. Okay, let's go to the binomial. Okay, binomial is because binomial can be viewed as a linear independent sum of the Bernoulli. So each xi is Bernoulli, right? So by definition, if you have a linear independent sum, then your phi xt can be just product of each characteristic function. So it's 1 minus p was plus p exponential it to the power n. And the mxt just change this to t, so 1 minus p plus p exponential t to the power n. Okay, so this is the binomial expansion, the binomial distribution. Okay, let's go back to the third. Is the geometry. So geometry is p 1 minus p to k minus 1 and k from 1 to 2 to 3 up to infinity. Okay. Right. So this is geometry. Okay. So let's prove this. Right. Let's first prove the moment generating function and change this function as the moment generating function by it. Okay. So this is moment generating function is sum of k from 1 to p 1 minus p k minus 1 exponential kt. Okay, so you pull out p divided by 1 minus p, so this guy becomes 1 minus p to k, exponential kt. And you see this is what? This is geometric series, right? So you change this to power k. And so this is the first term, 1 minus the ratio, so this guy, so it's p e to a t, 1 minus p e to a t. So this is just geometrical series formula. Okay, so geometrical series, to calculate the moment generating function and the characteristic function, we just use the geometrical series, right? So in this video, we already proved all these four, and I will see you guys in the next video. In the next video, we will prove negative binomial and Poisson and the first few of them, and maybe in the final video we will prove all of it, because all of this using the probability, using the properties of the gamma function. So knowing the gamma function is very, very important in the probability theory, probably the most important one. Okay, so I will see you guys in the next videos.